Hello everyone, this is Team Anthracite 2.0. Our PS code for SIH'23 is SIH'1338. Our problem statement is unpredictable failure of polypulleys along cable belt convey system for pulley changing. Coming to our idea aim, we know that in modern manufacturing, convey systems are vital for automated processes. But unexpected downtimes due to equipment failures result in substantial productivity and financial losses. According to a hypothetical industry report, unplanned downtime can cost manufacturers approximately $260,000 per hour on average. An estimation suggests that about 42% of maintenance tasks are either reactive rather than proactive, leading to increased operational expenses. In a manufacturing facility, the conveyor system experiences unexpected failures, causing frequent downtimes, leading to a productivity loss of nearly 15% annually. Reports indicate that 70% of these all the failures could have been predicted with early maintenance if proper monitoring systems were in place. Now let us look at some of the salient features of a model. It would consist of a predictive maintenance system using machine learning. It will also help us to reduce the cost and we can make many savings through it. It will also reduce the downtime and it will lead to increased equipment lifespan. Like if we'll keep a track of the health of the equipment, we'll be able to save more and also it will increase the lifespan of the equipments. Coming to the solution of a model, this is the whole diagram which represents the proper functioning of the model. There would be pulleys that will be fixed in the system and their health would be tracked through the sensors such as vibrations, the heat emitted, the load over the conveyor belts. So that the health of the pulleys can be tracked properly. If there would be any of the problem, it would all be sent through an alert to the department and admin. Also, all the data which has been provided to the cloud would be stored over there and there would be ML predictions based upon the data given. After the alert is given to the department and admin, we will be finding a solution to the problem. Now, there will be basically three types of department: electrical, mechanical, and safety department. So, whatever fault would be there, it would be categorized on the basis of department. Now let us come to a solution approach. It would consist of two parts, an admin dashboard and a department dashboard. The admin dashboard would include features data system overview, collaboration interface, safety alerts, mobile access, fault detection management, predictive maintenance, communication and records. Our department dashboard would consist all the three departments that are mechanical, electrical and safety and would display the faults within the location. It would also include department specific notifications such as warehouses and all the electrical records of the devices, and it will also consist real time analysis system. The next slide consists of the project flow diagram of our model. Now it starts with the user. The user can be of two types. It can be department or it can be admin. Starting up from here, the machine would send all the data to the sensors. Sensors would be retrieving the data and it will be storing it to the cloud. Now from the cloud, using various algorithms of machine learning, there would be fault predictions. Like whatever fault would be there, it would be predicted. If there is a fault, then it would be sent to the dashboard of the department and based on the fault, the department would take the action on it. After the fault has been resolved, it will again go through a check through it. In case there is no fault, it would be again stored to the ML database. Now, also all the security and safety issues will also be displayed on the dashboard of the admin. Coming to the application flow, the admin dashboard will provide a snapshot of system's health and performance indicators. It will also consist of the tools to review past data. It will also facilitate communication with hardware and software vendors, and it would also show the real-time notifications for safety issues as mentioned earlier over here. It will also allow monitoring via mobile devices with push notifications. It will also display and manage detected faults, aiding in resolution. ML based predictions to anticipate potential faults should be there. Logs and reports for past faults and maintenance activities would also be there. and there would be full access to the cloud stored information for comprehensive oversight. So, the admin will have all the cloud access. Coming to the department dashboard, it will showcase detected faults, their locations, and details specific to each department, enabling quick identification and response. It will also receive fault information directed to the respective department based on fault categorization. It will provide real time analysis tools, and our department dashboard will also consist of a graphical representation of various categories. It will also manage department specific resources and inventory to support fault resolution and maintenance activities. It will enable decisions based on data insights and analysis, and it will provide tools for intra-departmental communication, like all the three departments have the chance to communicate with each other and do collaborative work upon the faults. A third slide consists of the layout and prototype of a model. Coming to the dashboard of the admin here, you can see Ivana is the admin over here. So it will include features of real-time analysis. Like there will be fault displayed over here and how many faults have been resolved and how many are still left. This will all include the fault system. There will be fault rate and emergency avoided pie chart also over here, which will tell us that how many faults have we avoided in a certain period of time. It will also increase list of total faults, like whatever faults belonging to different departments. It will also be displayed over here, and provided data would be provided here in the this dashboard column. One can also search for whatever faults have been occurred till now and whoever has resolved the faults. Here is a search bar provided for the same. Next, coming to the department dashboard, this will include inventory and profit, and a sensor live feed, anomaly graph, and a fault area. There would also be warehouse details over this place. We can also see where the fault has occurred over the fault area section. Coming to the dependencies, we have server database, which are Ethereum or AWS managed blockchain for storing and updating data and getting historical details. It also includes logistic companies for getting GPS and sensors required, and we'll be needing cloud storage for sensor data storage. Coming to the salient features of a model, it will include real time alerts, data analysis and reporting, collaboration tools between different departments and the admin, maintenance management of records, and tracks resources for efficient upkeep. Now, the use case of a model include predictive maintenance and fault prediction, admin dashboard use cases, department dashboard use cases, sensor data and real-time alerts, historical data analysis and reporting, collaboration and communication, resource tracking, data security and access control, regulatory compliance and reporting, training and knowledge sharing, performance analysis, and continuous improvement and feedback. Now let us look at the tech stack of our model. So as told earlier, we will be creating two dashboards, that are admin dashboard and department dashboard. These two would be linked through Socket.io. We will be using React.js for web dashboard, and the server platform used here is Node plus Express combination. The database which we'll use is PostgreSQL. We will also use the cloud platform like AWS or Azure. We will be using blockchain for keeping the records safe, like there can be no intruder which can access to our records. All the IR and sensor info would be going to the cloud over here. We will be using Python to develop the model, like for ML basically is used here for predictions. We will be providing the data to the cloud. From cloud itself, it will take the data and then it will make different predictions based upon different algorithms about the health of the equipments. For data visualization, we will be using Power BI. For data analysis, we will use NumPy and Pandas, which are basically Python libraries. Power BI is a Microsoft open source tool for data visualization. On the right, we have the team details of our team. Prototype link is provided below. Thank you.